Hey, welcome to another episode of Introduction to C++. And today we are going to continue where we left off yesterday. So if you want to follow along, please go to, under the description, there should be a link to my GitHub and download this new edition, which is tutorial 4, loops functions, and we'll get started from there. If you want to create a new project, then go ahead. Okay, so yesterday we saw a couple of stuff. So we went over for loops, for each loops, while loops, do while loops, jump statements, where you get to set labels like we used to do back in, the olden days, I guess. And switch statements. Okay, so now we're going to be talking about functions. And we have seen functions already before. So this is a function. And I believe in number 1, we used a function to print out hello world. Right. So let's see. Functions. So this is the format of a function. We have a type. We have the name, and inside of these parentheses we have parameters, and more parameters, and more. Okay? And then here inside this code block we do stuff. And then we have return the value. Yeah, last time we said that, let's see. Don't think we said anything about it. Okay. Okay. So let's make a function. Let's make an addition function. It's going to take in two numbers, and it's going to do addition, and then it's going to return the value or the result. Okay? So we have to think about what kind of values we want to use, or types, data types. So if we want to not have decimal points, we would use integers. If we want floating values, then we'll get decimal points. So I would use integers. So that's our return type. And then we'll say the name is addition or add. and it's going to take two parameters. It's going to take int for A and int for B. Now, there's a few ways you can do it. If we put a semicolon right here, this is, we're declaring this function. We're letting the program know that we want a function of type of int to be called add and to have two parameters, A and B, that are both type ints. Now, if we just say this and try to call it, it's going to give us an error. It's not going to let us run the program, for one, because we don't have any declaration. This is just a definition. It is kind of like a label, I guess, that just says that we have a function somewhere that we want to use, and it's called this, and it takes all these parameters and it returns that type of parameters. So you can either, if you are going to define the functions right here after main, you would have to do this first, declare it, and then you can define it here. It's kind of like initializing it. Okay, so we have result, and we want our result to be A plus B. Okay, and now this function, if we have any type here other than a void, we must return a value. Okay, so what we have to do is, since we want to let the user access the result, we want to return the result. And this function, it's going to poop out this value right here. Okay? So you feed it. This is kind of like its mouth. You feed it, and then it processes that information, and then it poops it out right there. Okay? I know there's a lot of people, there's some people that don't really get functions at first, but it's pretty simple and straightforward. Remember, the name can be anything you want, except it cannot be any keywords that's already there. It can take parameters, or it can not have parameters. Now, these are I forgot what I was going to say. Sorry. Okay, so let's use it. Yeah. We are actually, so for this one, we'll just delete all of this, or you can just let's get all of this from here, cut it, and we'll just paste it here. And let me see. Okay, so we placed everything that we did on the last one instead of our comments, and what we're going to do is we're going to make a program. So let's delete this, and we are going to have it right there. Well, I guess we can make the program after we're done with whatever I want to show you. So we talked about declarations, which is just doing this. And we talked about the return value. So if you have a void here, then we don't return anything. We can ignore this. But since we are returning integer and we want to return the result of this addition, we have to do this. And let's now, instead of a program, let's make a variable called res and assign it that function. So let's say 10, 10. Okay, and this should come out as 20, and res should have 20. So res. Now we'll run it. And there you go. Add has 20, so it puts 20 in here. And we successfully got, I guess, the return value that this function poops out and stored it in our res variable, so we can use it somewhere. Let's see, what else do we need to talk about? So all these gone. Parameters and referenced parameters. Okay. So sometimes when you're passing parameters, let's say I have a structure, and sometimes structures can be huge. And every time you do this, pass it normally, it creates on the stack a copy of that structure. So here we're just creating a copy of the integer 10, and here we're making another copy. And this is fine because they're not that large. They're just 32 bits or 4 bytes each. But let's say you have a structure that's 100 or more bytes in size. Every time you call this function, you don't want to copy it every time. You would want to pass the variable by reference. So let's do some other function. And we haven't really talked about pointers and anything else, but we'll talk about this. Let's see. Let's make a function with the return type of void, and I don't know. Let's call reference param or passed by reference. Pass by reference. So we're going to pass an integer by reference. And this is the reference. Okay? So to pass something by reference, you have to put this ampersand right in front of the variable name. And so right between the variable name and the variable type, you want to put that. Okay? And this is pretty much the same as saying this. And a star means that it'll be a pointer. And we'll talk more about that later. But this is passing a reference, which means it's not copying anything. It's actually it's taking the address of that variable in memory. So we're actually passing the whole object itself to that function. So if we're not careful, we can actually change directly the contents of that variable. So let's call it reference, and let's say it's 100 right now, right? And we say pass by reference, and we pass reference. Now now let's do reference, and let's divide it by 50 or by 2, not 50. Okay. Now since we have a void type, we don't have to return anything. Okay? And then we'll just put it right here. We'll say reference, and reference. And watch what happens. We'll just disable that and run it. Now reference is 50. As you can see, we passed in this variable right here into our function. I'll make it bigger if you guys can see it. Sorry, I keep forgetting about that. So we passed a reference to this variable right here, to our pass by reference function, and we modified it inside here. You usually, or typically, let's get out of there, if we do it like this, what's wrong with that? It says more than one instance of overloaded function matches your argument list. I don't know. But if we do it like this without passing a reference, we're just making a copy of this variable and passing it into here, and then changing this variable, but not this one. Okay? So if we run this program like it is now, we're still going to, this is still going to print 100 because we're not changing anything directly, as you can see. Okay? But if we make it a reference, if we pass its address into this function, then we are not making a copy at all. We're saying, okay, here's this. We pass it over. They do whatever it wants with it. Well, actually, no. Like we give them like a card of where we are located in memory, and then they come over and they change it right here, and then we get something else. And notice that we don't have to return anything, which is pretty nice. So there you go. It's 50 right there. If we want to look at what happens exactly, or maybe not there, we can set a breakpoint and let's see. Let's delete that guy. And let's say reference right here. Where is our memory window? Tools, window, memory 1. Okay. So if here we type ref, or ref, we'll get the location of where this guy is located at. Okay. So where is it? There. When we go in here, we see that when we divided by 2, we actually changed, the references, the value inside of itself, its memory space. Okay. So, and then we returned from it, and then we print it, and it printed whatever that value was, which was 50. And that's that. Okay, so passing by reference. If you don't want to, let's say you don't want to change its contents, make sure you do this. Make sure you pass in a constant, because you cannot change a constant. See, like right here, it's giving us an error. It says expression must be a modifiable value. So since we put const in front of it, we can no longer change it. We can only reference it, which is get the value from it, but we cannot change its value at all. So this is how we can protect ourselves, I guess, if we accidentally try to modify something that we shouldn't. It's always a good idea, I think, to put a constant right there. Okay, so that's passing by reference. And that is the same thing as this. Okay. Now, see, when we're passing a pointer now, which is pretty much the same thing as passing a reference. We're still taking the address, and to do that, we have to say that right like this right here. So instead of the ampersand being on the parameters, it's going to be when we actually pass it into the function. So what this is doing is, like I said before, it's taking the address of this variable in memory, and notice that we get an error here because now we have to do a little bit extra steps to get the value, and to get the value we have to dereference this pointer, and we won't get too in depth with pointers at this point. We will look at them later because they are a whole new beast. But to dereference a pointer, all you have to do is say put the star right in front of it, and this will get its value, not its address, because pointers only, if we are doing this, we're telling it to point to a new location in memory, but we don't want to do that. We want to change the contents of it, and by dereferencing it, we are seeing what the value is and changing it from there. And if we run it, we can see that we do change reference to 50 again. Okay, so there's two ways of doing the same thing. If you guys prefer that, go ahead. Or if you guys prefer pointers, which you probably won't at this point. Okay, so let's move on. So we talked about parameters and referenced parameters and the differences between those. And I hope you guys understood what I was trying to say about references and non-reference parameters. If you didn't, please comment or send me a message, and so I can explain it a little bit better, hopefully. Okay. So inline functions. Inline functions. Let's see. Let's do a I don't know, subtract function, and we'll take A and B, and we'll do result equals A minus B. Return result. So here we're using the keyword inline. And what this does is when we call this function, well, we don't really call it anymore if it's like that, but let's say we have we're doing this right here, subtract 10 and result equals that, and we'll say sub. Now when we compile our program, the compiler is going to notice this inline a keyword in front of the function in its type. And what's going to happen when we compile this is going to be getting replaced with this. Okay? So what inline does is it just pastes this function right here. Instead of having to, I guess, find where it is and then setting up a pointer to this location for the return, and then jumping to this place in memory, and then running this code, and then when we get here, we would have to the stack will pop out, and we'll end up, revisiting or going back to the pointer that that the program or compiler sets for the return when we return from that function. And we'll talk about that a little bit later. But that's essentially what it does. So the compiler copies and pastes this function wherever we want to call it. Replaces Hopefully that makes sense. Okay, so you can do the same stuff that you do with regular functions. The only difference is that whenever you're actually calling it, the compiler is going to grab this and slam it right there instead of having to jump to it. So that's that. It's not much to it. You still have a return type, name, and some stuff to eat, and then you shit stuff. Okay, so we are done with that guy. Recursive functions. That one's fun. So, one type of recursive functions is a function that calls itself. Okay? Now, this might sound a little bit weird, but there's this thing that is useful in some cases, and it is used on some data types to perform and solve some problems. Okay, let's say we want to solve what this was. If you guys don't know what this is 5 factorial, right? So what is 5 factorial? 5 factorial, not percent, but 5 factorial equals 5 times, well, let's do it this way. N factorial equals n times n minus 1 times n minus 2 times n minus 3, and so on until we get to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, and it should be equal to 120. And if you do not believe me, we can say 5 and then hit this thing right here, factorial, and it is 120. So the purpose of having recursive functions is to make a big problem like 5 and make it as simple as having a 1, pretty much. Okay? So we're just taking a big problem and condensing it to its lowest form. That's all we're doing, and then it makes it easier for us to, and quicker for us to do stuff. So let's make that function, yeah? Let's return int, and we're going to call it factorial, and it's going to take a number, and it's going to be n. Okay? Now, let's have a little diagram over here and think about how we want this to emulate that. Sure. I'll take a look-see. Tutorials. Interesting. Anyway. Okay. So we have factorial, and we're taking in an integer. So we have 5, right? Because 5 factorial equals 5 times 4 times 3 times 2 times 1. So here we want to, let's say this returns an integer. So the way recursive functions work is that it goes in deeper. So we have a stack, right? And this is our memory stack. And we're calling factorial the first time, so we put it in right there. Well, hold on. Before we get into that part, okay. So we want to take this number and we want to check first if n is less than 1, or I guess we can do 1, yes. If it's less than 1, then we want to return 1. And if it's not, we want to get a result from factorial, and let's say this is n, and we want to do n minus 1. Okay. And then we want to return result times n. So what this is doing is we start with 5, right? We're at 5. We check to see if 5 is less than 1. If it's not, we go in here. Let me change the color a little bit. Okay, so we start up here. And now I guess we can talk about that stack. We're right here, and we are in step 1. And so this is right now n is at 5. We check to see if it's less than 1 right here. It's not. It's 5. It's greater than 1. So we go here. And we go back into this function again, which is fact. It's the same function. So we go in deeper, but we say n minus 1. So we are back here again. Okay, this time, oh shit, it's 4. So we go in here and we say, is 4 less than 1? No, it's not. So we go in here and we go in here. And now we have 3. So we're back here. We go here. 3 less than 1? No. We go here. We go back in here. Now we have 2. See, we're going back. We're stacking. As we go in further, we keep on pushing to the stack wherever we want to return. So it's this point right here. It's a little bit complicated, but kind of not really. It's just kind of hard to explain sometimes. But we are right here again, and we are n is equal to 2, and we check to see if n is less than 1, which is not. It's 2. So we go in here and we do this one more time. Okay? Then let's choose this one. We're here. N is 1. Oh, I guess we should say equals to 1. Doesn't really matter. So we check if 1 is less than. Oh, we'll just do it less than. Why not? Because we started with that, so we're going to end with that, right? Okay. So is it less than 1? No, it's not. It's 1. So we're going here, and we go in one more time. Okay, this is the last one. Let's choose that one. And now we're at 0. N is 0. We start here. We go here. Is it less than 1? Yes, it is. So we go in here. Once we hit return, we're going to pop this from the stack. Okay. So now we are going back in reverse order, pretty much. So now we're at n is 1. And Let's let's get the eyedropper and get that. So now we're at 1. So we are here. Result is going to be equal to 1. So we'll just keep track of it here. Result is 1. Then we go here. We return result times n. So what is n? N is 1 right now. Result is 1. So 1 times 1 is going to be 1. We return. Now we're at 2, well, and we pop 1. We're here again, because this is where we went inside of the function, and this is where it returns back to where we called it. That's where we left off. So we are back in result equals factorial n minus 1. Now n is 2 right here, and result is 1 again. So result is 1, and I guess we'll put n right there. N is 2. And then we go to this line. Then we have to return result times n. So 2 times 1. 2 times 1 is 2. So let's get the eyedropper and go one more. And we'll say 2 right there. And we pop n. So now we're here again. N is 2. I mean, result is 2. Then we go down here. Then we do result times n. N is 3. 3 times 2 is 6. So we return, and result is now 6. And we pop. Well, we don't, but you know, the memory stack pops you out of that structure. And we are at 4. N is 4. Result is 6. We're here. And then we go down here. Result times n. 4 times 6, or 6 times 4, is 24. So we go here, and then we say result is 24. And we pop from that place in memory, and we are right back here. Now n is 5. This is n. Result is 24. Then we go down here and we do the multiplication. 24 times 5 is 120. Sorry. So what happens now is we pop this from our stack and we return to wherever this first function was called, and we poop the value 120. So that's essentially how it's going to work. And we can actually see how it goes deeper and deeper into the function once we implement it and run it. So you can get a better understanding, because I know I probably didn't explain it that very well. I'll try to later on if you guys want me to, but yeah. So we check to see if n is less than 1. If it is, we return 1. If it's not, we want to say this. And then do that. Or we could just say if n is 1, then return 1 and do that. Okay? And we're just going to call it right here. Int fact equal, or let's call it n equals 5. Int result equals factorial of n, and we're just going to print it at the end. We'll say 5, or not 5, factorial is, so we do n, which is the whatever the factorial we're wanting to solve, and then we do the result. And yeah, we can do that. So we'll see what we get. You can see 5 factorial is actually 120. And if we want to see a breakdown, we can do this. And this will give us a breakdown. So it's, well, forget about the past this guy, because this is, the other print function. So what we're going to do is that. So I guess we do, just so we can print 1, we want to do that. So this is the actual factorial, which is 5 times 4 times 3 times 2 times 1. And that is going to be 120. So how does this work? So let's go in here and run it. And we're at here. If we we actually have something. I don't think I have it here. Do I? Call stack. Yes. So this is our call stack. I don't think I can make that one any bigger. But this is what our program this is the stack, the memory stack, and every function call gets pushed into the stack. Well, we can't see it from here, but every variable like these are in the stack as well. This is in the stack, and so on and so forth. And we will be able to see the hierarchy. So we see right now that we are in factorial line 161, which is right here. Okay, this is the first call to our function factorial. So if we go here, if we double click on the main, we can actually see where we got called from, and that is at line 188 right here. So we can see the hierarchy of how things get called in our program. So we can see that, let me just separate these a little bit. Let's put that one right there. Let's put the call stack right there. Let's put the watch window right here. And I need more monitors. And we can have this be n, and then this be result, and that'll be that. Anyway, so we're in this. We can see that result is not initialized because it's a negative whatever number that is. It's not initialized. It's not even declared yet, but it says it is here. Then n is 5. This is our start. And then we check blah blah like we did before. And then when we get to this point, we're going to go in here and pass in n, which is 5 minus 1, which is going to give us 4 right here. So you can see now that n is 4. And you can see here that we have another item in our stack. So if we go back, this is where we were called from. And then if we go back one more, this is where we were called from originally. Okay? So we're going to go in again. And if you look over here, you're going to see that it's going to add another one. And there you go. We added another one. And then our n is 3. Why do I have another n? I have no idea. Delete it. So n is 3, and we'll keep going. And we can see that we have another one right here. And then we have our n is 2, and we'll keep going. Our n is 1, and we have another call here. So we can see the hierarchy. If we go back one, we can see that we were called here, and n is 2 here. If we go back one more, we can see that n is 3, and we were called from here because here's the the little arrow that tells us where we are in the stack. We go back one more, and it's 4, and here we were called from. So that's where we are going to return. That's where we set, or it set, the pointer to go back to. And if we go back one more, and it's 5, and this is the first time we ever call this function. So if you can see that we have 1, 2, 3, 4, 5 different calls to the same function, but they all have different values if we go into them, because we keep on subtracting. Otherwise, it'll keep on going in and in and in and in if we don't subtract it. And the purpose of having recursive functions is to get the biggest number into the smallest possible number to be able to do the arithmetic or whatever, to be able to do factorials or the Fibonacci code sequence or whatever. So we go in here and we say n is n less than that. Yes. I mean, no, it's not. At least not yet. So we go in one more and we say n is 0. Now, is n less than 1? Yes, it is. So we go in here and we return. And as you can see, when we return here, we're not going to be out here. I mean, out here. We're going to be out here, actually. So we return. And you see that 1 went away because we popped it out of that stack. And we are setting result to 1, or whatever we returned here the first time. So, and then we do it again. As you can see, we keep going to that place, that same place where we call that function, because that is where the pointer to return or continue from is. And you can see how it works, pretty much. And if you look over here, if you have been looking at this part, it's the same thing that we were doing over here. Okay. Where are we? We're right there. And now we are back to the original place. And we print our factorial. And it is 120. So that is how recursive functions work. You can do recursive functions for pretty much anything. Like, let's say, how do you spell Fibonacci? I have no idea. Fibonacci. It's Italian. So here is the sequence. Let's see. So we would start from this big number and go all the way down. We could start from the 1 and then go all the way up, but it makes more sense to go from the biggest to the smallest. So, and here is the formula, which is n equals n minus 1 plus n minus 2. And here's a breakdown of that. And here's the Pascal triangle, which you can also do. And that one's a little bit more complicated. So yeah, if you guys want a challenge, I challenge you guys to see if you can make this happen, the Fibonacci sequence, with recursive functions. And we will see next video, the actual way that you would do it. Okay. Notice that there is a limit to how many numbers you can have here. Let's say if we do this, it'll probably crash because the stack, see it says stack overflow. We called this so many times that it ran out of memory. So you do have to be careful. These, I'm sure there is a way to get more memory in the stack, but I'm not sure how to do that yet. But do notice that there is a limit to how many objects you can have on the stack. I'm not sure exactly how much that would be, but I will do a little bit of research and I will let you guys know later on. Okay. So this will conclude our lesson for today. I hope you guys had a great time. I know I did. Sorry. If you guys want to continue, or if you guys want to follow along, please follow the link under the description to my GitHub repository and download the zip file. I will be uploading all videos or code samples into this repository. So yeah, check it out. If you liked the video and if you would like to see more, hit click, and if you will, you don't have to, hit subscribe as well. And I would really, really appreciate that. Thank you. Yeah, if you guys have any requests, don't forget to send me a message or comment below, and I will see about that, getting you guys your requests if we're not doing anything. So yeah, that'll be that. 1 hour and 15 minutes. That's long. Alright. You guys have a great day. Bye. Thank you.